Here we are discussing an interesting and important question from the chapter functions. Here question is, let R plus be the set of all positive real numbers and function f is defined from R plus to the interval 4 to infinity. Here this interval is closed with 4 and open with infinity and defined as fx is equal to x square plus 4, so that f is invertible and find f inverse. Invertible function means function is 1 1 and onto function. So for showing that this function is invertible, we need to show that this given function is 1 1 and onto function. Okay, so let us see the solution here. First of all, we'll show that this function fx is equal to x square plus 4 is 1 1. We'll show that this function is 1 1 function. Okay, we have f of x is equal to x square plus 4. Let us suppose that x1 and x2 are two elements of the set of positive real numbers. Okay, so here we need to show that if we start with fx1 is equal to fx2, then it will imply that x1 is equal to x2. Means if two images are same, then pre-images will also become same. Okay, so let f of x1 is equal to f of x2. This implies, using this definition, x1 square plus 4 is equal to x2 square plus 4. Here 4 will be cancelled out from both sides, or we'll get x1 square minus x2 square is equal to 0. And this implies that x1 plus x2 into x1 minus x2 is equal to 0. Here x1 plus x2 will not equal to 0, since x1 and x2 are positive real numbers. Okay, so sum of two positive will not be 0. So this implies that x1 minus x2 is equal to 0. This implies that x1 is equal to fx2. So here we have started with fx1 is equal to fx2, and this is implying x1 is equal to x2. It means this given function f is 1 1 function. This part has been proved. Now we have to show that this function f is onto also. So we have fx is equal to x square plus 4. In place of fx we write y is equal to x square plus 4, or x is equal to square root of y minus 4. It means with respect to this element y in range, we will get a pre-image in domain x, which is equal to root over y minus 4. In other words, in respect to every element y in the range, we are getting pre-image x, which is equal to root of y minus 4. So this function is onto function. So therefore this implies that f is onto, and as f is 1 1 and onto, so therefore f is invertible function. Therefore f is invertible. Clear? As we have discussed, a function is called invertible, means its inverse will exist if the given function is 1 1 and onto function, or you can say bijective function. Correct? So this part has been proved. Now next part, we have to find F inverse. Okay, so F inverse will be this much only. We can see it. We have fx is equal to x square plus 4. Let us put fx is equal to y. Correct. So therefore y is equal to x square plus 4. As we have written here, the same thing we will write again. This implies x is equal to square root of y minus 4. And x is, if fx is y, then x is f inverse of y. This gives us x is f inverse of y. So now in place of x, we can write f inverse of y. So we are getting here f inverse of y is equal to square root of y minus 4. This is the answer. This is the value of inverse function. It means that with respect to y, as we have discussed earlier also, with respect to y in the range of the function f, you will get pre-image square root of y minus 4 in the domain of the function f. Okay, so this is the value of inverse function. Correct? Okay, hope understood it. Very interesting. Okay, so remain in touch these videos. We have to see some more important questions, and hope you have subscribed this channel. If not, please get it subscribed and share these videos with your friends also. And if you are getting benefit, you are enjoying these videos, your likes are most welcome. And if you want to give any suggestion, or you want any clarification, or you have any doubt, please write in the comment box. I will definitely address it. Wish you all the best.